Yeah, thank you. Yes, my name is Dong Song. I'm a professor at UC Berkeley and co-director of the Center Berkeley RDI. So today I will talk about building an open, responsible AI economy. So as we all have seen and experienced this exponential growth in large language models and the modern AI, and these new technologies empower rich new capabilities, and a lot of these development has made a rapid advancement on AI model performance. Many of these AI models have reached the human level performance on many of the benchmarks. And we foresee a really exciting AI era where we'll have a lot of these agents, including, for example, personal agent assistants that actually is going to intermediate most communications between individuals and external worlds. And also we'll have a lot of diverse agents for solving different tasks. And in the future, we also foresee we'll have decentralized autonomous agents that will interact and act in a decentralized manner. So with this exciting AI era, there also comes many different challenges. So in particular, in this talk, I will focus on 3 key challenges. First is how can we ensure building a responsible, safe AI? And second, how can we ensure to build a user-controlled open architecture and protocol for innovation? And also third, how can we ensure responsible, fair data use and value attribution? So first, as we deploy AI, it's really important to ensure trustworthy and safe AI. And there are many different aspects for this in terms of the different challenges and perspectives, including, for example, hallucination, robustness, privacy, fairness, toxicity, and so on. So in the interest of time, I'll just focus on one example challenge as for trustworthy AI as we deploy AI systems, in particular with adversarial attacks on these AI systems. So my group has been among the earliest to working in the area of adversarial robustness in AI, and our work and others have shown that today's AI systems, they all suffer from these adversarial attacks. For example, attackers can simply just change for example, manipulate the inputs to the model, sometimes with even humanly imperceptible changes to these inputs, and then cause the model to misbehave. So for example, when we started working in the area, there are only a very small number of papers each year, but by now, actually, there are thousands of papers in the space each year. And also, we had the rare honor and pleasure that some of the artifacts from our earlier research adversarial examples in the real world, for example, on these stop signs, have now become part of the permanent collection at Science Museum of London. For computer science researchers, this is actually a very rare honor and pleasure. And also now, today, as we utilize large language models, we need to make them safety aligned, and adversarial attacks continue to cause huge issues on the safety aligned large language models. So one of our recent work called Decoding Trust has developed the first comprehensive evaluation framework for trustworthiness of large language models, where we develop new algorithms and frameworks to evaluate many different perspectives on trustworthiness for these large language models. And so the paper has won the Best Paper Awards at NeurIPS last December. And from our work, we have shown that these large language models can still be easily attacked and suffer from many different types of risks. Using our evaluation framework. So on one hand, we see that adversarial attacks are really effective, and also for the community has been really productive and creative in developing many different types of attacks on these large language models. As I have shown, that now we have thousands of papers per year on this topic. But however, on the other hand, the progress on developing adversarial defenses has been extremely slow. For example, so today we do not have effective general defenses against these adversarial attacks. So as this gap continues to widen, where we make rapid progress on adversarial attacks, but the defense against adversarial attacks has almost made no progress. This poses huge challenges for AI safety. So current AI alignment mechanisms are easily evaded by adversarial attacks, as I just illustrated, and any effective AI safety mechanisms need to be resilient against adversarial attacks. So this poses a huge challenge for AI safety, where AI safety essentially needs to address adversarial robustness first, and as I demonstrated already, where today the community has made almost no progress, and we don't have good defenses against these adversarial defenses. I won't have time to go into details in terms of what are the next steps that we can take on these defenses. So this is a recent initiative that we launched together with other researchers such as Yoshua Benjo, who's the Turing Award winner and pioneer in deep learning, on how we can develop better AI safety mechanisms with this initiative called the Quantitative AI Safety Initiative. So overall, AI safety will be one of the biggest challenges in AI deployment. And I'm also part of an international dialogue, efforts on international dialogue on AI safety, where a small group of leading researchers and scholars in AI and AI safety, we actually talk with governments around the globe to raise awareness on AI safety and facilitate international cooperation on AI safety. And one of our recent convening took place actually in earlier in the UK, and then recently in China, where we proposed a number of red lines for AI safety, where AI model development should not occur. So that's the first challenge on how we can ensure building responsible safe AI. So due to due to issues of time, I won't have time to go into other aspects of responsible safe AI, including how can we mitigate misuse of AI and mitigating loss of control. So now let's move on to the second key challenge for the AI era, which is how can we enable user-controlled open architecture and protocol for innovation. So as many of us have seen, so with today's internet, while it provides great utility and productivity for society, but it's plagued with many issues. In particular, today's internet is platform-owned, and as a consequence, users lose control and have very little influence, and essentially users are actually the products, and creators are also not being fairly compensated with their contribution. And overall, this closed platform hinders innovation. And these issues, if not addressed, will continue to worsen in the AI era, where, as we already see with the current developments in AI, again, it's largely controlled by centralized parties such as big tech. This offers very limited choices and control for users. So for example, in the future, if we don't, if nothing is changed, we even these personal assistants and so on, they will continue to be controlled by a big tech, which can pose challenges in terms of user control. And also today's closed platform lacks transparency and attribution, and also creates data silos where a lot of valuable data are also not being utilized for contributing to build better AI models. And as a consequence, essentially, with the current developments, we are the end result is a feudal AI, where instead we want to have a democratic AI. So how can we address these challenges? So the vision is that we need to build an open platform of AI assets and enable user and contributor control with decentralized trust. So one key reason that causes the centralized platform today is that the application services, they need trust, and this trust leads to today's centralized platform. However, with the recent technology advancement, essentially we can utilize new technologies to reduce the need of centralized trust, and instead we can have decentralized trust. So these recent technology advancements includes confidential compute and distributed ledger. So now I'm going to briefly talk about how these recent technology advancements can really help reduce the need for centralized trust, and hence enable building this open platform of AI assets. At Berkeley, we have been developing the first end-to-end open source secure enclave called the Keystone, based on RISC-V. Started back in 2018, 2019. So back then, we were also hoping that, so the Keystone is secure enclave confidential compute on CPUs, but back then, already we foresee that more and more of the AI workloads will need to happen on GPU. We're also hoping that the future GPU developments can actually have secure enclaves, confidential compute capabilities. So actually, back in 2018, the security architect of NVIDIA actually came visit Berkeley, where we had in-depth discussions about how it's not only feasible but also not too expensive to add confidential compute secure enclave capability to the GPU. So I'm really happy to see that now 5-6 years later, now finally we have this confidential compute secure enclave capability on NVIDIA's H100 GPU. And also, so back in 2019, we actually organized the first open source secure enclave workshop at UC Berkeley. And as the opening remark for the workshop, I gave a prediction. Back then, that was 5 years ago. The prediction was that in 10 years, most chips will have secure enclave capabilities. So now we have 5 more years to go. So I'm holding out for my bet to be true. And I think it's a really exciting time for confidential compute. So with this type of new capabilities in confidential compute, of course, it can enable a lot of exciting new applications and services. So here is just one very simple example that my group has done that you can actually try out on the website later. So for example, right now, when you use, for example, ChatGPT and so on, the data all goes to OpenAI, and you have to rely on OpenAI to honor terms of service if you want to opt out, not to have them use your data to further train their models and so on. But however, with confidential compute here, we can simply enable a confidential chat. Essentially, in this case, the model will be the model and the backend web server can run inside the secure enclave and the confidential compute environment using the latest GPU capabilities, and then now we actually have end-to-end secure services where users can securely talk with the LLM with all the data being kept in confidential. And also users can verify that this is the case. So that's just a very simple use case example that you can actually, again, try out on our website later. So what's more exciting is as we combine this confidential compute capability and distributed ledger, we can enable a new type of digital assets that we call AI assets. So these include, for example, AI assets based on data and AI models. And they are controlled by fine-grained, they can be controlled by fine-grained policies. So essentially, we have these data assets that are encapsulated and in an encrypted form with policies, fine-grained policies attached to it, and together asset plus policy together is called a manifest. And these manifests are signed and integrity protected contracts that can provide fine-grained control of asset use. And these asset rights are enforced using policy and payment engine to using confidential compute technology and digital ledger. And with this combined technology, we can enable operations, a wide spectrum of operations on digital assets. We can provide the full tracking of provenance and usage of these digital assets. And we can enable decentralized access control and policy compliant computing on these assets. And this will enforce fine-grained rights and policies defined by data contributors and model developers, and enable privacy-preserving model training and inference. And also, with all this tracking and policy enforcement, it then can also enable disbursements of payments to data contributors and model developers based on the terms defined in the policy and also values contributed to these assets. So with this technology, with the AI assets and the confidential compute and distributed ledger technologies, we can further enable the reduction of friction and trust needed for collaborative learning. So, using this technology, we can actually enable new a next generation of playgrounds and sandbox for collaborative and collective learning. So in this case, for example, model developers can try out data provided by data contributors in the playground. If the data doesn't help, then the playground can simply erase everything. And in this case, the data contributors don't lose anything. And if it helps, then the final trained model can be packaged as a model asset. And this asset can be governed by usage policies and value attribution and sharing terms that's specified by data contributors and model developers. Using this approach, also it will make it much easier for model developers and of different models and different data contributors to collaborate to build better AI models and services. And further, we hope that this technology can enable much larger scale of collaborative and collective learning scale to many decentralized entities with both rights enforced and also value attribution and distribution enforced as well. Here is a high-level overview of the technical architecture for this open platform for AI assets. This open platform is designed to have to be open, enable interoperability, and enable wide integration with a lot of different stakeholders and different subsystems operated by different parties. So for example, with this open platform, we can provide aggregated data marketplaces where data contributors provide their data assets, including these encrypted data with policies attached to them. And also enable aggregated AI model marketplaces that enables, again, different model assets with usage policies and terms associated with them. And these developers can utilize the data assets and also model assets in these marketplaces to further train and fine-tune models based on different base models. And this computation can also happen on a decentralized confidential compute fabric, which is based on a computation based on a compute marketplace that's decentralized as well, that connects to essentially globally widely distributed and decentralized compute facilities. And the trained models can then be utilized by different AI service developers to provide diverse AI services. And these AI services can also be aggregated as AI service marketplaces. And these AI services are policy enabled. And then users can use these AI policies where these policies are being enforced, again, using the underlying confidential compute decentralized compute fabric. So with this decentralized AI services running on this open platform for decentralized these AI assets, we can also, here is an example illustrating the flow of value which are being enforced by the terms and service and policies specified and attached with these different AI assets. So for example, as users use the AI services, these AI services will accrue value. And then given that this whole platform tracks how essentially tracks how the usage of these AI services and also can enforce the terms and policies, it can then disseminate, distribute the value according to the specified policies and terms to the model developers and to data contributors and to the different stakeholders and also to the compute providers as well. To enable this open platform for AI assets, we need a number of supporting technologies, some of which I have already mentioned, such as confidential and distributed compute. In addition, we also need decentralized identity, decentralized access control and secret management, decentralized policy compliant computing, and also data valuation and value contribution, and also game theory and incentive design, and also agents, and also decentralized agents framework, and so on. So my group and also other researchers have done a lot of work in all these different domains of supporting technologies, including some of our earlier work on data sovereignty that actually defines and explores the space of decentralized access control and decentralized policy compliant computing. So with this, another open question is how then, given all these AI assets, how do we actually ensure responsible and fair data use and value attribution, right, in this case. So as we all know, data is the lifeblood of AI. Unfortunately, today, there are a number of issues with data contribution. So first, there are a lot of data is sitting in data silos. Valuable data is not being utilized. Second, creators and data contributors are not fairly compensated for their data contribution. So how can we enable better incentive? How can we better incentivize data contribution and fairly distribute value? So with my right, so my group has been was among the first to actually explore this question, and in particular, we developed the first rigorous framework on data valuation for machine learning models, utilizing a framework first developed by Shapley, called Shapley Value. And Shapley is a Nobel laureate on economics. And the high-level idea of this Shapley value-based data valuation is that we essentially model each data contributor as a player in a collisional game. And the value contributed by the data contributor is based on the marginal contribution of the data contributed by the contributor based on the utility of the model. So now I have discussed these three key challenges for the open era. And to summarize, when we look into the future, so first, nation states leaders have mentioned like whoever controls and leads in AI will rule the world. And unfortunately, let's look at what is the status quo today. So this actually, so this small part is actually from a presentation that I gave in 2018, 6 years ago. So that was actually the last, the AI wave. And so when we look at the status quo today, is that we have this big attack where in this closed platform, where each big tech actually is building essentially profiles of each individual user in the walled garden, and using their services to essentially provide services to end users. And they can provide driving directions, career advice, or even life plans. So the question is, in this case, who will be running our lives in the future? So with the current paradigm, essentially we'll be having these big tech closed platform that's who will essentially be running our lives, who has the goal of maximizing value. So is there a different future? So we hope that in the future, we can have intelligent agent, personal assistant that's actually under user control, that will be interacting with users to provide these services to users, and at the same time to interface and interact with external services provided by third parties. So the important difference here is that instead of maximizing company values and revenues, these personal assistants that's under user control will actually be maximizing user value. So this is the aspiration that I talked about back in 2018. And I think with today's AI advancement and development, this issue is only more daring. So again, to summarize, the problem with today's platform-centric approach is that a closed platform has today the The whole society is running on this closed platform with full stack locking and walled garden. And the centralized platform decides on value attribution and distribution. And users have very little control and privacy protection, and have very little choices and bargaining power. So in the future, we hope to build what I call an open, responsible AI economy. In this open, responsible AI economy, we can, again, as I mentioned, have these personal assistants that actually is under user control, that they can provide services to the user with the goal of maximizing user value while interacting with other agents provided by third parties. And there are three key pillars for this open, responsible AI economy. First, openness, to provide users with choices, transparency, provide community governance, and enable accelerated open innovation. The second pillar is responsibility, to ensure a safe, trustworthy, and responsible AI. And the third one is to enable a democratized AI economy to reduce friction, disintermediate, and enable value attribution based on contribution. And there are a number of foundational components to the three pillars, enabling where we can, with frictionless data contribution, where everyone can contribute to all of their data, and to break down data silos and give AI back to the people, and enable sharing of computational resources, where we can break down computational silos to allow anyone to contribute to developing cutting-edge AI, and enable fine-grained control for developers and communities, where, for example, model developers can enable fine-grained controls on their models, enabling novel business models, and also not just having this binary choices of whether to keep the model open or closed, but actually to enable more fine-grained usage policies, and enable transparency, verifiability, and auditability to provide the observability needed to ensure safety and equitable use of AI assets. And also this can support for assessing and comparing AI models, and to enable interoperability and composability, to enable free remixing of different AI services, like what open source does for software, and finally to enable community governance and safety. So with this open platform, it can also provide a key contribution to public good for AI safety. We can have decentralization and community governance to facilitate a bottom-up consensus on what safety properties are most needed. And also this open platform can dedicate a huge percentage of its, for example, collective proceeds for AI safety research and technology development, to enable AI safety development as a public good. And also the open AI economy can disincentivize harmful models and incentivize the creation of technologies to mitigate, again, the various AI risks. So with that, I hope that everyone here can join this journey and efforts to build an open, responsible AI economy. So with that, so first, as I talk about agents, as I mentioned earlier, so this fall, Berkeley will be offering a new class on large language model agents, and the class will also be available online to students online. So you can check out more details here. And also for this efforts on building an open, responsible AI economy, you can sign up to a mailing list here to stay tuned for further progress. So with that, thanks everyone.